The Stateful session registry is a component responsible for managing session state across distributed nodes in the Meridian cluster framework. Sessions represent logical connections between client applications and server instances. Each session maintains an immutable identifier, creation timestamp, and last access time. The registry stores these sessions in a consistent hash table distributed across cluster members. All write operations to the registry are serialized through a monotone clock mechanism to ensure ordering guarantees. Sessions are created through the register session function, which accepts a client identifier and optional metadata dictionary. The function returns a session handle containing the assigned session ID and initial heartbeat interval. Metadata parameters are stored as key-value pairs with a maximum combined size of 16 kilobytes. Registration is an atomic operation that increments an internal version counter and logs the operation to the replication journal. Failed registrations result in an exception with error code session registration failed. The heartbeat mechanism maintains session liveness across the distributed cluster. Each session has a configurable heartbeat interval, defaulting to 60 seconds. Clients transmit heartbeat messages to any cluster node at regular intervals. Upon receiving a heartbeat, the registry updates the last access time for that session. If no heartbeat is received within 3 consecutive intervals, the session transitions to the stale state and becomes eligible for cleanup after an additional grace period of 180 seconds. Session state transitions are governed by a finite state machine with 4 primary states: active, idle, stale, and terminated. Transitions occur only in response to explicit operations or timeout conditions. Active sessions respond to client requests and heartbeat messages. Idle sessions have not received heartbeats but remain within the grace period. Stale sessions exceed the grace period threshold and will be cleaned up during the next maintenance cycle. Terminated sessions have been explicitly closed and retain minimal metadata for audit purposes. The registry maintains a time series index of session creation and termination events. This index supports range queries for administrative auditing. Query operations accept a start timestamp and end timestamp parameter, both in Unix epoch milliseconds. The index is stored in a separate columnar format optimized for sequential scan operations. Range queries return a bounded result set limited to 10,000 entries by default. Pagination is supported through offset and limit parameters passed to the query interface. Session metadata storage uses a flat key value encoding scheme with string keys and polymorphic values. Values support primitive types: integer, floating point, Boolean, and string. Complex types are not permitted at the metadata layer. String values are limited to 2048 bytes. The metadata dictionary is updated through the update session metadata function, which accepts a session identifier and a partial metadata object containing only the fields to be modified. Metadata updates do not trigger session transition state changes. The close session function terminates an active session and marks it for eventual removal. Closure requires the correct session identifier and an optional closure reason string. Closing a session that is already terminated or does not exist returns an error with code session not found. Upon closure, all pending requests associated with the session are rejected with status code closed. The session record is preserved in the registry for a retention period of 30 days before final deletion from the audit log. Session lookup operations are performed through the getSession function, which retrieves the current state and metadata for a given session identifier. Lookups return a session object containing the identifier, state, creation timestamp, last access timestamp, metadata dictionary, and replication version number. getSession performs a distributed lookup across cluster nodes using consistent hashing. If the session is not found on any node, an exception with code session not found is raised. Lookups have a default timeout of 5 seconds. Replication of session state across cluster nodes follows a log-based approach. All state changes are written to a append-only replication log before being applied locally. The log entries contain the operation type, session identifier, timestamp, and complete session state snapshot. Primary nodes initiate replication to replica nodes asynchronously. Replica nodes acknowledge receipt of log entries after applying them locally. If a replica falls behind by more than 1 million log entries, the primary initiates a full state transfer instead of log replay. The maintenance cycle runs periodically to clean up stale and terminated sessions. The cycle is triggered either by elapsed time or when the registry size exceeds a configurable threshold. Default threshold is 1 million active sessions. During maintenance, the registry iterates through all sessions and identifies candidates for deletion based on state and retention period. Deletion operations are batched to reduce impact on concurrent read operations. The maintenance cycle is designed to complete within a fixed time window and does not block incoming heartbeat messages. Concurrent access to the registry is managed through read-write locking mechanisms. Session lookups acquire shared locks, allowing multiple concurrent reads. Write operations such as registration, heartbeat updates, and metadata changes acquire exclusive lock scope to the specific session record. The lock implementation uses a spin-then-wait strategy with adaptive backoff. Lock contention is reduced through partitioning the registry into multiple independent hash buckets, each with its own lock. Deadlock prevention is enforced through consistent lock ordering. Error handling in the registry follows a hierarchical exception model. All functions declare expected exceptions in their signatures. Session not found is raised when operations reference non-existent sessions. Session already exists is raised when registration attempts use a duplicate identifier. Session closed is raised when operations target terminated sessions. Session timeout occurs when operations exceed their deadline. Cluster unavailable indicates that replication partners are unreachable. Callers must handle these exceptions or allow them to propagate to higher layers. Configuration parameters control registry behavior and resource allocation. The heartbeat interval seconds parameter sets the default interval between heartbeat messages. The stale threshold intervals parameter controls how many missed heartbeats trigger the stale state. The grace period seconds parameter sets the duration before stale sessions are cleaned up. The retention days parameter controls audit log retention. The partition count parameter sets the number of independent hash buckets. All parameters are read at startup and require node restart to take effect. Monitoring and instrumentation of the registry is provided through a metrics interface. The registry exposes counters for session registrations, closures, and state transitions. Gauge metrics track the current count of sessions in each state. Histogram metrics record latency distributions for lookup and update operations. All metrics are tagged with the node identifier and replication role. Metrics are collected at 1-second intervals and exported in standard Prometheus format. The metrics interface does not block normal registry operations. Backup and recovery procedures for the registry leverage the replication log. Full backups are created by taking a snapshot of the entire registry state at a specific log position. Incremental backups contain only log entries since the last backup. Backups are stored in compressed binary format with integrity checksums. Recovery from backup restores the snapshot and then replays log entries up to the desired point in time. Recovery can be performed to any logged state, supporting point-in-time restoration. The registry initialization process occurs when a node starts or joins the cluster. The node loads configuration from persistent storage and validates all parameters. If the node is designated as primary, it initializes an empty registry. If the node is designated as replica, it downloads the current state from the primary through full transfer. After initialization, the node enters the ready state and begins accepting heartbeat messages and client requests. Initialization failures are logged with specific error codes and prevent the node from becoming operational.